afternoon, everyone. Welcome to Dr. Science. Let's see how we can solve a question like this. A satellite launched with velocity v subscript e just escapes the Earth's gravitational attraction. Given that the radius of the Earth is r, show that v equal to square root 20r, and we are advised to take the value of g as 10 meters per second squared. Now, this is under Newton's law of gravitation. It's easy to solve this. Now let's go and see how we do it together. Okay, to solve a problem like this, I mostly advise learners first bring out all the parameters given to you and their symbols so that it can be clear to you. Now we have escape velocity. Escape velocity, we are to use v subscript e. Acceleration due to gravity g, the value is 10 meters per second squared. Radius of the Earth, capital R, is also given. Now we are to show that this formula is true for escape velocity for this satellite. Now, let's say mass of the satellite, what should it be? Let's call it small m. Then let's say mass of the Earth. Mass of the Earth, let's use capital M. Don't forget capital R is radius of the Earth. Now assume a rough sketch. Here is the Earth, here is the center. The distance from the center to the circumference of the Earth is the radius of the Earth. And on this circumference you have this satellite whose mass is M. And of course this is the Earth whose mass is capital M. Now, if this satellite has to escape the Earth's gravitational attraction and move free by itself, how much velocity is required? Of course, there are different ways we can approach this. Let's look at, from Newton's law of gravitation, we know that force of attraction between the Earth and this moon should be given by this product of the two masses over square of the distance between them. And we know that the weight of the satellite is mg and is the same thing as this f. So this f and this f are the same and is equal to the weight of the satellite. Okay? Now, this satellite is inside the gravitational field of the Earth. When an object is in a gravitational field, it possesses potential energy. Now, potential energy, gravitational, for this satellite is given by force, which is mg, times distance. Okay, so this is mg r. Of course, from law of conservation of energy, this gravitational potential energy will be converted to kinetic energy, which is energy of movement of the satellite. So the kinetic energy of the satellite should be given by mass of the satellite square of the escape velocity over 2. Okay? Now, I hope this is clear. That said, the total energy of the object has to be constant. That means potential energy must be equal to the kinetic energy. Now, what is the potential energy from here? mgr equal to mve squared upon 2. This m will cancel this m. So you have gr equal to ve squared upon 2. Okay? When you cross multiply, you see that 1 times ve squared will give you ve squared equal to 2 times gr will give you 2gr. Of course, we are given the value of g as 10, so this is 2 times 10 times r. So we have ve squared is 20r. Now, to make this subject of the formula, you square both sides. So the square will cancel square root. We'll have ve equal to square root of 20r. And with this, we've been able to show that this is true as given in the question. Now, what if somebody wants to approach the same question from another perspective? Of course, it's true. We realize again the weight, which is mg, is equal to gravitational force between the two objects. Okay, so when we do this, m will cancel m, so we have g equal to this. Okay, I want to make gm capital subject of the formula for a reason. So I can call this equation 1. Okay, having done this, I can say work done against gravity must be equal to the kinetic energy of the moving satellite. Now, what is work done? Force times distance must be equal to ke. The force is g, mass of the earth, mass of satellite, over r squared multiplied by r, this r, over 1, should be equal to m ve squared upon 2. So this r will cancel 1 here. If I do that, I'll have gm capital M small m upon r remaining, since 1r has cancelled 1 here, equal to m ve squared upon 2. Then small m, mass of the satellite, eliminated. We have g capital M upon r equal to ve squared upon 2. When you cross multiply, okay, you have ve squared r equal to 2gm. That means v squared r is 2gm upon r. Okay, I hope you are getting what I'm doing. Okay, let's assume I just got that. But we know capital G, capital M product is gr squared. So we can say ve squared is equal to 2 over r, this 2 over this r. Now this product gm, I'm going to write it here as gr squared. So this r will cancel 1 here. We have ve squared equal to 2gr. And of course, square root of both sides. We have ve equal to 2gr. Remember, this r was given as 10, so 10 times 2 is 20, so which is true as what we got earlier. So Malam, I hope this will help someone out there understand how to solve questions like this, especially escape velocity, not the same thing as the rotating velocity of the satellite. Thank you.